Hello, hello. I'm glad to, well, I'd say I'm glad to see you, but I don't see any one of you. But I'm glad you're there, whoever you are. Welcome to this talk that's never been given before, so I hope it's not too bad. It's called The Surprising Costs of Void and Other Not So Quite Innocuous Evils. So you can see my name and email addresses there for my various jobs. It's very intimidating to pass after Mr. Brown this morning and Lisa around noon for me, because they're such great speakers, but let's do our best to do something nice. I will suggest that since I have a single monitor set up at home, I'm working from my laptop, that you put your questions with some context on the Q&A section, should you have any, or comments or threats or whatever you want. And my extraordinary volunteers will relay them to me at the end, and hopefully we'll be able to answer a few of them, because I haven't timed myself, so I have no clue how much time this will take. Of course, if there's anything, you can still write to me, or you can always write to me afterwards. I'll be glad to speak with you. So, as you can see, if you haven't seen me in the past, I'm a father of 5. There's 2 at home these days, only one that's home currently because she has a cold. There's a number of animals in my house, and I happen to be in my house. So if you hear dogs barking, or birds chirping very loudly, or animals like cats putting things on the ground, it's because that's where I am right now. I'm in a setup that is more animated than I usually am when I give a class. In my past, I worked flight simulator code for the military, and I've been teaching for a long while, which is what you see. And I'm also a WGA21 member, but I haven't been in meetings last year because I'm too busy. It's very sad because I love meetings. So, about this innocuous evil thing that I want to talk about today. So there are things that we let pass by us without noticing, because we're busy people and we do things and we have utmost confidence in our skills and the skills of others. And yeah, so there are things that are kind of bad cold smells that sometimes we don't pay enough attention to, and that come back or come by and bite us or play tricks on us. Some of them are even acceptable in some cases, as you can see. So you can have a code review and they will just pass because you weren't paying attention to that detail that day. Do you respect the language? They compile. So some people think it compiles, it works, which is a very interesting concept. And sometimes the code even works. You can have broken code that works by chance. And yeah, why not? When I prepared this talk, the idea came from students of mine last year coming back from internships and bringing back assignments with things that surprised me as being acceptable to them and to their employers, because sometimes it was inspired by work they did at work. But what really inspired me to do this talk was that some of my colleagues, whom I respect and who are very intelligent people, didn't see the point of my reactions sometimes. So I say, well, okay, so there's something there that even experienced people with skills, a number of interesting qualities, technically speaking, just accept as okay. And yeah, sometimes we need to take a step back and think a bit more about the code we write. So there's not going to be anything spectacular in the code today, but there's going to be a lot of code. Yeah. So evil comes from context too. Goodness is contextual, evil is contextual. So sometimes we take an example that's too simple, but yeah, we take it as good because, why not? It works in the slides. We don't always mean to be evil, but sometimes we are. And sometimes we are trying to apply a practice that is good in one context or one language that doesn't fit in the language we're using. For example, something like this, which I see quite a lot from people coming from Java or C#, say, and they're trying to write C++ code, and they do something like this. So, of course, this code compiles, and it leaks. It's very, very bad C++ code, but because it's not idiomatic, but it's idiomatic in other languages where someone is able to collect the garbage that you produce. Yeah. The one on top there is closer to what we expect from C++, of course. You won't prefer to throw objects instead of things that you have allocated in a dynamic fashion, or even better, the one at the bottom where you actually have a class that expresses intent more clearly instead of something that's more general. That's what we've gone for in C++. So that void paren thing, there's nothing inherently wrong with them. They are everywhere. Let's see examples of very good ones. See, this one is very good. It's a greeting function that provides a very interesting message that's significant and meaningful, and that's being called by main there. So it's an innocuous program for starters, and it's fine. So there's nothing bad about the fact of having a void parent function. They exist. They have a right to exist. They creep up in examples all over the place. They are of limited usefulness because they have no inputs, no outputs, except for global state or I/O. But still, And void functions, well, in some languages, your main is a void function. So you can write a void parent function in Java or C#, and you'll end up with something completely correct. Even the one we have in C++ is int, but we mostly treat it as a void function because we don't care about the return value all that often, to be honest. With member functions, void parent is a bit creepier. It doesn't mean it's always bad. No, there are reasons, but something like this, you have a mutex, you call lock, it's void parent, that's fine. That's fine because your mutex is a state. It's representing state, and you're mutating that state along the way, which is kind of the point. That's okay. So the examples that I'm going to be using now, they actually come from anonymized code that came back from the internship students and from other sources that I saw in the last year. I C++ified them in a sense, but some of them were JavaScript code, C#, Java, C++ too, of course. So yeah, this is actually actual real life code. Okay, I think it makes me react, but that doesn't make everyone in my entourage react. So I have this function, see, that fetches keywords, I guess, from a vector of string passed by a ref, probably to avoid a copy, I guess. Fetch from where? Fetch from where? Is that from the argument? Why is it mutable? Where are those keywords going to go? Maybe inside the state of the manager, I guess, in this case. So yeah, there's something strange about this. The argument is not const, this is not const, so there's mutating things elsewhere, I guess. This actually came from real code too, get stats. No args, no return type. Well, void. So a void function that starts with get. That gives me shivers. It makes me feel bad. And I'm looking at this, where do those stats come from? From a file, I guess. Where do they go? In some global state. It's a plural stats and a plural stats. That kind of makes sense, I guess. But why get? This at least tells us, well, they probably came from a file. I guess there's an argument. It's already a start. It's a bit less creepy, but still. Yeah. And they're non-const. See, so these functions are non-const, so we can kind of expect them to be mutating state, presumably if the person who wrote them kind of gets C++ and const correctness. This is interesting too. See, find args. So I'm looking at this and I say, okay, there's a pass by value v, and there's a pass by ref args. So I'm guessing it's going to find args somewhere, but not in args, obviously, because it's const. Since it's not const, it's mutable. So I'm looking at this, I'm trying to guess what's going on. Well, maybe it will look for arguments in v and put them in args. So why is it not static? What's wrong there? So those void functions with weird signatures, well, they sometimes pass code review because obviously this came from actual businesses that sell and ship software. This is also real life code. You can see that the return type is void again. It's called edit word, so it's initializing, I guess, the state of v in this case, as we can see. But it's being passed a vector as argument, which it's filling, which leaves one, I guess, to wonder why is it not using a local vector and returning it instead. But sometimes this comes from people used to old style C++, pre-C++11, that maybe might not get RVO or something and are guessing that this is the right way to go, don't get move semantics. But that comes from real code. See, a void function again. This is a void parent again, as you can see. So I'm guessing it's going to create inside the class some state, but it's a suspicious name still. I don't know about you, maybe it's current practice in your business, but create, get, make, convert, count, There's verbs like that you don't expect to see. I don't at least expect to see associated with void functions. But I see them all over the place these days. Yeah. So our interfaces, they talk to us, they whisper, they say things in our ears, they carry meaning. Well, they should carry meaning. And void parent, they kind of carry absence in their signature. There's no input, there's no output. They have to rely on things unknown. That's creepy a bit if you think about it. Doesn't mean they're always wrong, but yeah, to me it's kind of a cold smell these days. There are some virtuals that are lying around out there that we don't necessarily want. When I wrote this slide, I made a smile because it's written what's wrong with this picture. If you look at it closely, you'll see it's not C++. And for a number of reasons, this dot, string with a big S, public all over the place. You know? So yeah, it's Java code. I'm not going to be bitching about Java or C# today, by the way, because there's C# later on today, but I'm not going to bitch about it. It's just Java code. Yeah, so I wondered if I put this, how people would react. I know that JF 2 days ago, we had a bit of comment about Java and he made it very, very, very low. There's nothing really wrong with this class if you think about it. It respects the practices of the language. It's the kind of code that you will see in the examples at the official documentation or in books. Yeah. But if you haven't done much Java, you might miss this one. This function it's a virtual function. Java did virtual as out instead of opt-in. It was actually seen as a good thing way back. So this is an actual example of Java code that makes a student a person, that extends word there that you see. It's for public inheritance because there's no other kind really in Java. And well, there's interface inheritance, but it's still public. And that get name there that you see in the student class, well, it's calling the parent with super get name because there's only one parent. It's a single inheritance model. And yeah, in the main, at the bottom part, you can see that the person is associated with the student. And when you're calling get name, you're calling the get name of student. It's a virtual call. There's no keyword for that. When you talk to a Java person about virtual functions, they don't get what you're saying. Well, some of them don't. So the non-constructor, non-static member functions are virtual in Java. And you can use final to opt out, kind of like we do in C++ to halt virtual. And that was seen as a good idea. I remember instructors of mine, when I was a student, tell me how good that was and how bad the other languages were not to follow suit. So C# and C++, if you notice, they ask you to opt in to virtual instead of opt out. So it's a cool mechanism when you need it, but they don't impose it on you because there's costs. And this is a virtual, this is a C++ class now. And if you look at it closely, you'll notice something wrong again. I'll help you. There's this thing there. This I see in actual coding guidelines for some companies. Some companies impose you to put that. Why? Well, I guess with in books, they used to say that this was the right thing to do. If you do size up this with 1 box, which is a recent GCC, you'll see that it's 40 bytes. 40 bytes, even though the string is not that big, because there's a VTBL in your class, because you had at least 1 virtual function, so it has to generate more stuff. You know? If you just remove virtual, well, you're going down to 32. Well, you just saved 8 bytes per person, so it's kind of nice. You know? It's not for 1 person, it's for a whole set of persons that it becomes interesting. So why do people recommend that? Or where do some people recommend that? Well, they should maybe get on with the program of C++ because it's been a long while since we've known that you shouldn't spread virtual all over the place without reason. It's part of the design, see? But some books say you should do that, and some schools sadly still say you should do that because some instructors, I guess, should maybe get their act in shape. Because people used to think about object-oriented programming as hierarchies of classes with virtual calls. Jared spoke about that earlier this week. So this is very unidiomatic to C++. And if you play with that old school kind of object-oriented programming from a C++ perspective, of course, because in other languages it's fine, well, it plays against you. That's not what C++ is good at. C++, it works. You can make it work, but it's not necessarily a recommended way to do things. So yeah, and if you do something like this, what you see in the slide right now, which is probably what you would see in a book too, they would tell you, oh, well, your destructor here is very dangerous, you know? because you have a virtual function there, of course, and your destructor is not virtual, so it's suspicious. Because if you do something like this, and you have a derived class, and you're expecting the derived class's destructor to be called if you go through a base pointer or a base reference, well, you'll notice that it won't be called, which is wrong, which is bad. But of course, if you have a virtual function, it kind of makes sense to have a virtual destructor. If you go through some base class pointer of some kind, you hope to delete the right thing. You know? So sometimes you do need one. You do need one, at least typically speaking, when you have another virtual function, but there are reasons to have just a virtual destructor sometimes. I know use cases for that. You can write to me if you want to know about them. But you don't always need them. You don't want to put them all over the place. It's making your code bigger, and there's nothing coming back at you. There's no benefit. Well, in most cases, at least. So it implies adding a VTBL. You might want to use dynamic cast or something, but again, if you don't have any other virtual service, why would you do that? No? So it's fine if you do that, if you have benefits. But if you do that mechanically without thinking, that's hurtful. Yeah. The problem is the mechanically, the out of edit thing, the not thinking before coding thing. That's very, very bad. We'll get back to that. I often have discussions with people about this issue, like, should we initialize everything to 0? There are advocates for that, or to some value, or initialize everything, whatever. I have an interesting case there. See, this main function is trying to read an integer and print something if it's odd. But mandating in such a case, initializing n to 0, it's a bit counterproductive. You're going to write to it in a second, isn't it? So it's just 0. Wait a second. It's not just 0. It's more complicated than that. There might be other impacts to that initialization in the machine. There's another one there. There's an array, if you might see, initialize with zeros. And then I'm putting values in them afterwards. Well, the initial initialization to 0, it's not necessarily a zero cost thing there. You're not in the you don't pay for what you don't use kind of category in this case. Well, you're using it, of course, so you are, but still, what's the point, This again, this one is more innocuous, but I'm still calling for the default constructor of all my strings. So this is a non-trivial array I'm creating there. There's costs in there. There's a number of function calls in that line in bold. It's not trivial. This is something. So making a vector and then reserving instead of resizing in such a way that you allocate the space without initializing the things, and then pushing back the strings or emplacing backs. We'll get very similar code in this case. Surprisingly enough, though, I tested this because I was convinced it would be faster, and it depends on the compilers. For some weird reason that I don't know, some compilers still do better with the array and the vector, even though they're paying for the initialization. So there might be interesting optimizations that the compilers see that they can do because it's like trivial new or something. But still, conceptually speaking, I have less wasted code in this case than in the previous one. Module optimizations that the compilers do because they're very, very bright. Yeah. Annoying. I'll go back a slide. This is annoying because it's difficult to write efficient code if the optimizer is so good that the things that look good look bad in the end. So usually you should measure what you're doing. This is another case. I'm using a string view. String view is good. I like string view myself, and I'm storing a string. But there's wasteful stuff there because most of you will probably know, I wasted the default constructor of my string in person because I'm overwriting the default value with something else with an assignment. You'd be surprised, especially when you're mixing people from different language backgrounds, at how many think this is a no-cost operation because they're used to strings being references to some immutable thing outside, because that's what it is in Java, JavaScript, or C#, whatever. And in this case, well, we have an actual object, and assignment has different meaning. You're not pointing to something, you're replacing content with something else. So there's a cost to the default object that you just created, in this case, for nothing. Of course, as you probably know, we can do better than this. if you have a guideline that's telling you do not leave any variable uninitialized, well, there can be really big costs for nothing. If you look at these two, F and G there, the one in F, which is generating values in an array, as the array is essentially trivially initialized, essentially at the beginning, because the values, we do nothing with them. And the bottom, I'm zeroing them before generating the values. Well, if you look at the generated code, you see there's a totally wasted mem set there. So maybe there's upsides to that. You have to see on some specific hardware, but it's wasted code mostly. So some guidelines you have to wonder, is that, do we take them too literally maybe? Or is it the right thing to do? Yeah. So there are ways to reduce that problem, though, especially for those to be initialized variables. So those that you could put a default value in there, but you're going to override them anyway in a second. So you're kind of wondering if it's a good thing to do. So the first thing you can do to help yourself is write shorter functions. So short functions, they tend to make that problem kind of go away or be very, very restricted to a very small space. And the second one is declare variables when you're using them, which we use not to tell people not to do like a few decades ago, but with the languages that we have today, well, it's pretty much the best thing to do. So you declare your variables when you're ready to use them. And in this way, you use your constructors instead of assignments, and you have less junk lying around all over the place. So if you take these two together, you tend to get a lot of benefits, especially sometimes you can benefit from RVO, which is pretty nice. I took this one from Mr. Lavave. I hope I spoke his word right. Stefan, if I made a mistake, I'm sorry. It's a nice class to show how move semantics work to people, because it's just a class that does nothing, but tells you what it's doing when it's doing nothing. So it's telling you if I'm doing an assignment or a destruction or a default constructor or what have you. So if you're trying to figure out what your code does sometimes, and if you're doing the right thing, well, it leaves a trace to let you think about what you're doing. So look at this code for a few seconds. So you can see this code starts at the first line of main, noisy n semicolon, and then it's calling n equals f of n. And then you have function f that takes n by value and does a few things. So take a few seconds. I'm going to take a slight bit of coffee, look at it, and think about what it's going to print on screen. Normally, most people are pretty much okay until the return in F, and then it becomes a bit more hairy. So you probably guessed that there's a default constructor in there, and then there's a copy with the call of F of n, and then there's another default constructor with an F for variable m, and then there's an assignment, and then it becomes a bit more complicated to follow. So this is pretty much what you're going to get, see? So the first line is the n in main, the second one is the n in F, the third one is the m in F, then you have your assignment. And interestingly enough, after that, you have the move assignment, because there's no point for F to keep M intact, because it's going to die anyway. So it's moving out. And then there's the destructor of your local M, of your local N, and in the end, the destructor of N in main. So that's pretty much what's going to happen in this case. So yeah, there's a lot of noise there. And this is not very good code. So if we just make this little change, so let's go back one, see? Noisy m equals n in F. And then you go look at this. This should lead to the same kind of behavior, but since we are leaving a trace what we're doing, we'll see a difference in this case. We're replacing a default constructor in an assignment with a copy constructor, because this is a copy constructor. And this is actually better code than the previous one, because assignment requires to remove what was there before and put something else instead. So it's most of the time it's more costly in construction. So fair enough. Now if you make it a bit simpler, whoops. This is a bit nicer and becomes interesting slightly. Sometimes people overestimate this one. So if we go back one, we had this, where we made a local copy of n in m and then returned that local copy to this, which just returns n. Going back again, so I had two copy constructors and a move assignment. When I get there, sometimes people hope for a lot of code to be removed, but a bit. See, there's a move constructor being used there for the return value because the local will be destroyed at some point, and you have to make it temporary and stuff. But this is pretty much what you end up with. It's nice. There's still your move assignment. There's still 3 objects involved. Yeah, because there's the thing being returned from F that has to generate some code at some point. Now look at main now. That noisy n equals f of n. This is unpleasant because we're suboptimal in the way we write code in this case. If you put it this way, this is starting to get nice a bit. See, I was using, if I go back one slide again, I was using a default object that had a name to pass to f, which will return something with it. So if I just remove the name from the default object and just create it on the call site without naming it, so I am enabling interesting things. More than you might think in this case. I'm enabling the move initially instead of a copy because it's an unnamed object. But the real gain in this case is that I'm creating n from the return value of f, which enables our view. This is pretty neat. So this is a significant upgrade in code quality. If I go back 2 slides, look at this. Then I move up 2 slides. It's pretty significant. Pretty nice, isn't it? And this is just code hygiene. Now, if you look at this one, whoops, not this one. This one is actually funny. Think about it for a second. This makes sense if there's only one f and its argument is default constructible. But still, it doesn't generate any better code, by the way. It's just funny because you go in a bar, have a beer with people or a glass of something interesting, and you put that and they think it doesn't work, but it works fine. It's not any better and you won't get a job with it, but it's amusing. Yeah. And of course, this is even nicer because you see there's only the minimal stuff that we need to do in our code. And of course, well, the benefits are very strong. So unnecessary initialization, if you compare from the beginning to the end, just paying attention to what we do, there's significant gains. Yeah. So when you have a very small scope for a variable, you can turn the code at the top with the variable n declared outside of the if into the code at the bottom where it's local to the if. That's actually pretty neat. Thomas Koppe did that. So I like that feature a lot. Some people don't, but I like it. Of course, this supposes that the scope of your variable is local to your if statement and the accompanying else if any. But yeah, the uninitializedness of n is a lot less annoying if it's kind of part of the same statement in a sense. So this might meet the expectations of your company if they really want things to be initialized whenever you use them, because it kind of looks like it. And of course, there's ways to go around it. If n has to live longer, you can use an optional of some sort. So there's this consume function that I put there that returns an optional int that might or might not be initialized. But yeah, it works. But it's a bit, there's a custom space. It's a bit more involved. I'm still wondering why we should initialize these things if we're about to anyway write to them just after. But that's me. So if you write very long functions with uninitialized variables at the top that you might use at the bottom, just write shorter functions. That's your best bet. Yeah. C# is a weird one. It's interesting to talk about it. I'm not going to push for that, I'm telling you right away, but still, they have out arguments in C#. So out are pure outputs. So the caller doesn't have to initialize them. The callee has to write to them regardless of what it does. It has to write something. Even if it tried to do some I/O and it failed, it still has to write to the variable. So when you have a call like the one on top, int n, f out n, that means f has to write to n. So you can pass an uninitialized variable to the function. That's perfectly fine. It's written like this. You can actually call it, as you can see a bit below, f of parent out int n. So this looks like a signature. It's missing the return type, but it's actually a valid call in C#, and it's a declaration, and a definition, of course, of variable n at the call site, and it lives from that point on in the scope in which it is. But it's just too weird for C++, and I don't really like it. But the advantage of this is if your company has a guideline that says you have to initialize your variables when you declare them, well, this forces initialization. You're sure that after the call to F, it will be initialized. But I still don't want that in C++. It exists. So let's return to these things that we do without thinking, because they're bad. So this is personal pet peeve. Again, it's Java code. It's not because it's Java. I don't mind Java. I don't like it, but I don't mind it. But what I mind is that get and set pair that people write without thinking. Maybe, sometimes it makes sense. Sometimes your tool forces you to do that because it's idiomatic in the language, and people take a habit of doing that. But is that a proper interface? Why would, in general, you need a set and a get for everything in your class? Is that the proper interface? Is that appropriate to the domain model, the model domain? C# is the same thing, but a bit shorter because they have this property thing where you have both gets and set. It should be public in this case. I forgot to put public on it. But why? Why would it should be public for my example, but why systematically put gets and sets? What's the point of that? Does it describe the right thing? Is it the proper interface what you're doing? Maybe it is, but it's not mechanical. It's not something that should be automatic. So I'm surprised when I look at the code people write, how much of it is mechanical. It used to be a bit tied to wizards. I noticed the old wizards that we have with some of the IDEs that we use, they used to generate code. They're not necessarily very good code. But people, you would say, like create class and have boilerplate class that would have been faster to type by hand, but it was something like that. It was very bad before. I tested it recently for the slides, and today it's much better. But still, I'm not sure it's worth going through a menu to do that. So there's nothing bad with gets and sets. Of course, you can write them if they make sense. The point is, should you write them without thinking in a mechanical manner? That's a totally different thing. Again, it's astonishing how much of that code I see in a week. You have to know that being a professor, I see code written by people who are beginning their career in humongous amounts every week. So, and what surprises me is that when they get a job, they still do that. So there's other things that we should think about before, like just writing them. You know? So things like this. Now I have this this default constructor there. I have master's degree students who do that. They put default constructors everywhere, and I ask them what it means. And sometimes they haven't thought about it. They just did it. See, in this case, what's a default person? Well, it's a person with a null name, because when you're doing new in Java something, it will initialize the references to null inside. So does that have meaning in your code? Maybe, but I'm guessing not. You could do that too, but then you have an empty name for your default person. Does that have meaning in your code? Maybe it does. Maybe it doesn't. But it deserves to be questioned or thought about. In C#, same thing in this case. I have the same principle. The name can only be read. It should be public again. It's my mistake. But the default constructor in this case will give me a null reference. So I'm getting a null name for my person. Was that the intent? Unclear. And even this, you have this default feature, but default for a reference gives you a null. It doesn't give you an empty string. So you still get a null reference in this case. People sometimes write that thinking, well, mechanical code, this is the things we do. But we should think about these things. And again, is a person with an empty name a proper person given the domain that you're working on? Might be, might not be, but the question deserves to be asked. It's not necessarily better in C++. The code that I have here in this case, I did the same thing. I have a default person. So I'm getting an empty string because my string is an object, not a reference to an object, but still, should I have done this? Should I have done this? So interfaces carry meaning. This is the kind of thing that my friend Tony would talk about, Tony Van Eerd. So if you can make sense of a default object of some type, well, that's fine to have a default constructor. But what would a default person be? I don't know any. I don't know any myself. Maybe there are. But there are reasons to do that. Sometimes you have concepts that you want to make regular. You want to make arrays of some type T. So fair enough. If it makes sense to you, go for it. But think about it. And we have to be wary without interfaces without clear meaning, objects without clear meaning. We have to be wary of them, at least look out for them. This is another weird pet peeve that I have that people sometimes do mechanically, and it scares me, to be honest. So we have this integral division thing that throws if you're trying to divide by 0. Fair enough. And there's some important computation going on at the bottom. Now, if you look at this, it's initializing some value to -1, and then it's trying to do the division, and it does the try-catch right away, and then it does what some people think as error management, which is outputting something on screen and going ahead and continuing. That scares me. If it doesn't scare you, it probably should. The initialization at first is a sign that something is wrong. And we have an exception there that doesn't want to be cut. It's a small, creepy, crawly monster in my code. Didn't want to be cut in the first place because there was nothing in important computation that would let me do anything about it anyway. I'm not doing anything with it. I'm just outputting on screen. There's no management to speak of. Why do I even put the try block there? It doesn't make any sense. But some companies will force you to do that. They will say, you need a try block when you have something that can throw. No. And just the fact that we have some unnecessary initialization is a sign that something's wrong in my code. Because I'm doing this in case the try block fails. What's the point, really? What's the point? So when I see companies that say all exceptions should be caught, sometimes people take that as should be caught at every step. That's a mistake. That's a mistake. You have to have something to do to catch an exception. If my function, in this case, important computation, cannot meet its post conditions, maybe that would be the right place to stop. Why continue? I don't have anything of meaning to work with. Yeah. And if I have to catch the exception in my code because that's what's being asked of me, maybe this is not the right place to do so. Maybe it just go up and up and up until someone has enough context to react. So this follows the letter of the law. I'm catching and then rethrowing again. Then what's the point? Why did I do that? I have nothing to manage in my code. Anyway, this makes sense. Seems nice. It's simpler. And if it fails, so be it. Let the exception go back up. Maybe someone will know what to do about it. And if you really, really need to catch everything, well, first of all, you need some context to do something about it. And then you can just do this. Just catch everything and do some last-minute action to complain that something went really wrong. Well, at least you followed the letter of the law. You have done what was asked of you. You can put your main in a try block and be done with it. For those wondering, yes, this is totally fine C++. There's nothing much you can do in the catch block, but it's there. This is important. The more you do non-C++ code, the more you miss const. We're lucky to have const. Const correctness is not for speed, it's for hygiene. It's for the quality of the message we're sending. So look at this class. It's something made for some kind of very, very small and hypothetical game. But there's const member functions, there's const arguments, stuff. It makes sense. Let's remove all the names. See? So I took the same class, abstracted the names away. My interface still has meaning. Const is telling me things. So I'm semantically disconnected from the original, but there's still information I can gather from the types. I can see that my arguments won't be modified. I can see that I have non-mutating functions. I can see that I have a potentially mutating function in this case too. So I know things about my class because my interface is clearer, in due part because of the presence and absence of const, because absence tells us something, as others have said before me. If I remove all the consts, it becomes much more difficult to reason about the code. There's nothing here telling me what's right and what's wrong to call given some circumstances. I have to read the documentation, I guess, and hope for the best because the compiler is not helping me anymore. So why isn't all C++ code const correct? Because it should, why not? Well, there are reasons I understand myself. Some people, lots of people I meet come from other languages, the concept doesn't even exist. So why would they think about it? They've never seen it in their lives before. They don't know what the const member function means. Sometimes you're integrating code from some other third-party library that doesn't have any const correctness built inside. So it kind of makes sense that you have to bend the rules a bit. Sometimes you have work environments that don't believe in it for some weird reason and say, well, you put const in there, you're going to get into trouble. It's bad. Everyone knows it. That's scary. The quotes down there are reworked from actual quotes I got with actual people doing work in the field and selling software. I'm telling you, you put const somewhere and it spreads well like gangrene. It's going to be everywhere. And someone else told me, well, I put const somewhere and I ended up duplicating every function. That's terrible. That's funny. So if you look at this code, this code is some kind of old C function. See, that's getting a char star as argument. And I'm trying to call it with the const char star. Of course, it's going to complain in main because I don't have the right types. Because I have a constant, a pointer to const, and I'm trying to send it to a function that doesn't protect it the same way. Const is transitive. So yeah, so we could have people complaining, well, you put const in there, you get what you deserve. No, well, I'm not losing functionality by putting const. I'm being clearer about my intents. The problem is there, see? It's there because the function might not want to modify what I'm giving it, but it's not saying so. So the compiler is helping me. It's an interface problem. The interface is wrong. Interfaces tell us things. They whisper to us. This is better if you can, of course, control the code you call. This is cool because you can give it a proper interface with respect to your needs. There we could do better than const char star in this case. I know string view would be nicer and everything. This is what I mean. So using const solves the problem. The interface is better. And yes, sometimes you do not control the function you're calling because it comes from somewhere else and you don't have any control over it. And yes, you can constcast if you're convinced that what you're doing is fine. But the good thing about constcast is it's loud. So you can see that you did that. And at some point in the future, maybe hopefully fix it. So being loud about the lies you tell to the type system is a good thing. It's still a lie, but it's something you can find. It's something that speaks to you. It tells you there was something weird there and I went around, I have a reason. A bad one, but. And people saying, well, you put const somewhere and you'll have two versions of everything. Const is bad, it spreads. Well, it's kind of true. So I have this small array class there, very, very simple elements of type T, initialized to the default value of T in this case. And I have my iterator interface that's no except, fine, why not? Begin and end, non-const, and a non-const operator bracket, because it's an array, why not? And that might be sufficient for some needs. Of course, if you make it const correct, you're doubling, effectively, you're doubling the number of functions and the number of types in my case. So I have a const iterator instead of on top of the iterator, I have a const begin, a const end, and a const bracket. Yeah, it's more code. People could complain that the blocks of code inside are the same. Well, they're syntactically the same, not semantically the same. I know there's a proposal to simplify this in the works right now. I don't know where it's at, but I've seen it pass by and I read it a few times. So yeah, I have more functions. That's true. But they don't mean the same thing. It's not the same interface because it has a different meaning. That's why it's there. That's why it's different. It doesn't express the same ideas at all. So if we limit ourselves to this one, which is not const correct, of course it will compile for most cases that I use, I guess. But if I'm trying to do some kind of print function for my type that does a loop or something, I'm trying to write it this way, well, passing a const array to the function makes sense, const array by reference, because I'm not trying to modify the elements, I'm trying to read from them. But that boldface array of I there, it won't compile, of course, because it's non-const. It doesn't offer the guarantees expected, and the compiler is protecting me from my own idiocy. Yeah. So it's good that I use const at the border of my interface. It's sad that I don't have the guarantees transitively asked in my member functions to carry on that interface. So it's a different meaning. I'm gaining something from it. Of course, not everything will be doubled. You have functions that have only const versions. The empty and size functions in a vector say there's no reason to make them mutating. I hope, at least. And there are those that are imminently mutating, so pushback, insert, or such arrays. Well, they won't be const. That makes sense too. And those that have two versions, well, it's because they have two meanings. That's fair. There are shortcuts we take in code. I know you know them. I wanted to call this one of union, reinterpret cast, and C/out casts. But I wanted something more general. And we could have volatile to that, because volatile is a bad name. Some people think things about volatile that are not true. And volatile is like a bad word. JF is very courageous, JF Bastien, to have taken on volatile recently, because it's the kind of word that nobody wants to get close to because it's severely underspecified in some senses. So there are things we do to make things work. We fixes, quick and dirty things, compile, runs, works. Yeah, let's move to something else. And then at some point it comes back to us. Write once, debug many or something. I tried to put examples up and they itched. I felt bad writing them. They creep like spiders on your skin sometimes. So what I did instead was I took a real life example that I anonymized. But it used to come, because it's not there anymore, I checked. If it is, it's in an archive somewhere. It comes from a well-known company that sells software. It was in the official help section in its original form. I had colleagues and people I met in the industry that used that example in real code thinking it worked, because it kind of worked in the context in which it was used. So it's like this. So I might be saying something about the interface there, but there's non-portable code, but it's part of the meaning of the problem. So I have this shortcut, u-long for unsigned long, because otherwise slideware doesn't fit well. And launch that takes a function. std call means, in that context, a non-C calling convention. So it tells you that the arguments are not going to be called the C way. The order will be different and the way they're passed. Anyway. Who's responsible for putting them on the stack? Who's responsible for removing them from the call stack? It's not a C rule that applies, something else. So it's launch that takes a pointer to a standard call function that takes a void star and returns a u-long and a void star. So it's going to call the function, passing in the argument, or so we can guess, or something. So imagine that launch f of arg will call f of arg at some point, asynchronously, whatever. And that thing, as I was saying, it tells you that it's the non-C calling convention thing. So the stack will be handled a little bit differently if you call it. So you have to be careful, because if you're playing with the way the arguments are passed and removed from the stack, and you're not being conformant with yourself, you might corrupt the stack, which is not the best thing to do in your life. So, and I have this function that almost meets the requirements, except that it's not a std call. It's a C function, a C++ function, because it doesn't have any qualifications to speak of. So it's a C calling convention. Now, if you do something like this, launch of f of null PTR won't compile, because you don't have the right pointer type, because it's taking into account the fact that you don't have the right calling convention. And if it did pass, in what state would be your stack after the call? But I've seen that. So that was actually an example in the documentation. So FP is the type of the function that you are supposed to be passing to launch, and a C-style cast to say, shut up, let me do my thing. Now, if you compile this thing and you run it, it compiles without errors. You're given the proper compiler, and you run the code, and it returns 0. Because in this specific circumstance, there's nothing after the call, and you're just passing an argument that's very simple. It's a pointer to null. There's no local variable anywhere. It's a very, very isolated test case. It works. But it's so bad. It's so bad. It's just short, but yeah, it passed code review in companies I know. People thought it was okay. So we can lie to the compiler and we can cheat the type system. There's always or almost always an escape hatch that does this kind. It's pragmatic. You can do that with C-style casts, but it's hard to find afterwards. You can play trace with unions or interpret cast, but I'd advocate the loud lies because they leave more traces. Yeah, and this one was very dirty. Time flies. I'm trying to go fast. I love lambdas. They're cool. When I teach them, people love them. They take to lambdas and they play with them, and it's one of the things that they appreciate the most after a few weeks. This is a very simple sequential number generator. Whatever you call gen in this case, it will increment the value of n, return a new value. So this code will print 0, 1, 2, 3, 4, which is fine. If you look at n after the sequence of calls, ln will be worth 5 because it's the local variable to n captured by reference by lambda. You put it this way, still compiles very fine. If you run it, well, you get what you deserve. Might work, might not, you don't know. Depends on what happens in your machine, your optimizer, or anything, because you're capturing a local, by reference, the local variable n to generator, which at the end of generator is not there anymore. So what's going on? Your guess is as good as mine. But it compiles without the noise. So if you're thinking compiles means works, you're gonna have fun. Yeah, it's broken code land, but it's very silent. You can put it this way. The parents are necessary with mutables so far. I think it might have changed for C++ when I didn't check. That was, I think JF suggested that, among others, but this one works. No? This one is fine because it's a local variable that you can mutate and get the right results. So you have to be careful. Now, our tools are getting better with this. So I saw good warning messages recently from some compilers with this. This is a factorial. It's a tentative trying to write a recursive factorial as a lambda. It won't compile though in this case. It won't compile because the compiler doesn't know what facto is at this point. It doesn't met the semicolon at the end of the lambda. It doesn't know what we're talking about. And it's not captured on top of it. So if you capture it by reference, it becomes a naming thing or a typing thing. Now, if you do it this way, saying, well, this lambda is a function double int, it's going to capture a function and work, and it's going to output 120 because that's what it gives. It's a complicated and costly way to compute the thing. It's tempting to do a function that returns a factorial like this. If you look at this, it looks nice. It does the same thing. And the problem is that, of course, if you run this thing, it might boom on you. It might work because it's undefined behavior, it might not or something, but you get a reference in facto in fact to itself. But that facto in fact is a local. When you're returning a copy to this, well, the local is still in the function, technically speaking, it's dead. And you're referring to something that doesn't exist anymore and you're on your own. Yeah, there's a fix. There's a fix. The fix is put it in lambda that will call facto and then put it. It's a very contrived way of doing things, but if you want to make it work, yeah, it works like this. So some of these examples are very tricky. Some are diagnosed by compilers. Some are not diagnosed at all. Some compilers will actually use undefined behavior and mask the bug and compute the right quote result, maybe because of inlining or whatever. Some will give you code that crashes. The last one I showed you, it was undiagnosed by all the compilers I checked. They might even pass code review, except that it's recursive and people will say, ooh, but still, you know. So we sometimes don't pay attention. We cut corners short. We take shortcuts. We try to deliver the stuff. We let things pass code review that probably should not have survived the code review step. We should think more. We should think more. Michael Case has talked sometimes about this. Recipes are good to get you started, but they're not enough. You have to think about your code, about what you do, about how you do it, and question yourselves. See, because we're not safe. That's how it works. Are there any questions, comments, threats, or anything else? Oops. Are we okay? Oops. Everything should be const by default, and we should use mutable. Okay, this is the Rust point of view. I'll talk about that in my that thing in my in my talk tomorrow, if you don't mind. But yes, const by default would be nice, but we have to remember that C++ was written 40 years ago. And our view of coding has changed, our view of efficiency has changed over time. So yes, it would be nice. We're doing that with new stuff if you look at it. Lambdas are const by default now. But yeah, that's not what we have as a language. So changing that would be tricky. You can write your own code to take that into account. Be const correct. That's good. What's the benefit of trivial set and get over just making a public field? If you're not doing any processing or any validation, there's not much of a change. But if you're planning to at some point validate things, having a get or a set to check things is better. I'd say that if you're using a reference-based language instead of a value-based language like Java or C#, your best bet is probably to make sure that your objects are immutable for the most part, because otherwise it gets very hairy anyway. So a good trick, if you're wondering about public fields, is if if your object has no invariants, public fields are fine. So if you have a point x, y, z where all values are okay, and you don't want to track changes in them, just use public fields. That's fine. So yeah, if you want to do something else, but think about the interface. There's always a reason for what you're doing. So if you're having gets and sets, it has to be because it makes sense. And additional answer to that would be, I have a lot more gets than sets in my code. Sets, they should be pretty rare in practice. The best place to modify your object is the constructor in the assignment. Isn't the main problem the strange cases at the beginning, the lack of documentation? Oh yeah, but you see, the question is, are the strange cases at the beginning, are they due to lack of the documentation? If we had proper interfaces and correct signatures that are, and correct names, no, if we had paid attention to the interface, we could document on top of it, but we wouldn't need to document all that much. When you have to write comments, to explain what you're doing, that's okay. When you have to write comments to explain what your functions mean, maybe more work should be put in the interface in many cases. I've seen talks in CppCon this year that had functions that I couldn't fathom the role of just by looking at the interface. So it touches every one of us. Have you tried stabilizer? Hey. No, I would need to. Stabilizers, I like the stabilizer talk yesterday, but I haven't tried it. So yes, it would be interesting. But my guess for the question is, have you tried tools like stabilizer to ensure that your performance measurements with reserve and the array are independent of layout? My guess, to be honest, is the optimizer is very good. And it's probably noticing that it can remove the useless initialization with arrays because it sees through my code. So I wasn't clever enough to obfuscate that fact. Does that mean every state transition with a class should be represented as some type plus data? The word every is scary in the question. Is that the correct answer? The things that, questions like everything should be like this or like that. My point is think before coding. So you can consider that if you want. But it would depend on the domain what you're trying to represent would be my answer. Think about it. Would you have a static analyzer suggestion to catch some of these bad practices? That's a good question. I would have to think about it because, if I take the first one, avoid parent function, it can be fine. Lock in a mutex, it's perfectly fine the way it is because my class represents state. So, but if my class is using, I'll take the words of someone else, If your code looks like you're using global state all the time because you're storing everything in a global object of some kind, you're in trouble. So that's probably the point there. So if your interface represents state, it can be okay to be void. So are they bad practices? Not all the time. Now it's tied to the semantics of the problem you're facing. So I'm not a static analyzer expert, but I would think about that before implementing a rule. For those who are interested, the recent versions of Visual Studio have static analysis built in. And for me, at least, sometimes they give false positives. But that doesn't mean they're bad. It just means that it's difficult. Is accidental avoidance of aggregate status a possible side effect of mechanical special functions? Interesting. That's a deep question. The one who wrote that one to me, I would like to have more context to understand what you have in mind, because it's interesting, but I would like to think about it more. So if you could write to me by email, I would appreciate it. Is there anything else? Because I think we're over time. Are we okay? I'm getting a new question. Do you think Lambda should have access to its instance and be able to call parent or create its copy? I think should it or should it not, I would have to see the use cases. But I can tell you that if you have to do more than what the Lambda does, yeah, that's okay. If you have to do more than what the Lambda does, you can always write a function object. By the way, just like that, I don't mind myself the word functor. It makes sense in the computer science sense. It's been like that for decades. So yes, it has another meaning in other domains, but that's fine. There's many words like that have different meanings in different domains of science. So yes, if you have the use case for lambdas to inspect their own instance state and call their own operator parent or something, show me the code, but you can always write a function object if you need to do that. Thank you, everyone. I would have liked to see you. I hope you weren't too bored. I hope you had fun. So thanks for coming. Bye-bye.